awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Assalamualaikum and hi everyone, welcome back to my channel. Jadi dalam video kali ini, kita nak buat lagi beberapa soalan dalam chapter 9. Dan jika anda pertama kali hadir ke channel ini, selamat datang saya ucapkan. Jika anda pernah hadir dan kembali semula, tahniah kerana rajin dan sudi kembali. Jadi dalam video kali ini kita akan buatlah beberapa soalan berkaitan dengan chapter 9. Jom kita mula. Okay, example 7. So here we have displacement equation. Okay, soalan ni kalau diperhatikan lebih kurang sama je, tak susah pun chapter ni. Okay, so given that the equation is x equal to 6 sin pi to t, where a is measured in centimeter and t in second. Show that the acceleration of the particle is given by, so this is the equation of the particle, okay, so the equation of acceleration in terms of t, okay, so dia suruh kita show lah, okay, so senang saja kan, so given that x equal to 6 sin, okay, cumanya kat sini dia ada pi dekat luar ni, masukkan ke dalam, okay. So, dia akan jadi macam ni lah. 6 sin 2 pi t. Alright. So, in order to get equation of acceleration, we need to differentiate first. Okay. V is equal to dx over dt. Okay. So, dia akan jadi 6 d dt sin. Okay. Differentiate sin akan jadi cos. So, you akan dapat 6 cos 2 pi t. Don't forget to differentiate 2 pi t. Okay, dalam ni. Okay, so differentiate 2 pi t akan bagi you nilai 2 pi, where v is equal to 6 times 2 pi. Okay, so cos 2 pi t. So v you akan dapat 12 pi cos 2 pi t. Okay, in order to get equation of acceleration, we need to differentiate equation of velocity respect to time t. Okay, where it is equal to d dt. So, v is 12 pi cos 2 pi t. Boleh? Alright. So, you akan dapat berapa tu? Kiralah. Differentiate cos akan dapat negative sin. Lepas tu jangan lupa yang ni bawa pergi ke depan lah. Okay. So, you akan dapat 24, negative 24 pi squared cos. Sorry, sin negative. Differentiate cos akan dapat sin. So, cos negative sin lah. So, here is negative sin. Kenapa tak jadi? Okay. So, negative sin. Okay, so kita dapat, okay. Dia suruh show saja. Therefore, ini kita dah show. Okay. Okay, so B. Calculate the maximum velocity and maximum acceleration of the particle. Okay, so based on the equation, as we have v is equal to 12 pi cos 2 pi t. So remember, the value here is actually v maximum. Therefore, tak perlu kira pun, saya dah dapat nilai v maximum saya, which is equal to 12 pi and it is equal to 37.7 cm per second. Okay? Kalau kata boleh tak saya nak kira? Boleh, tak ada masalah kalau you kata you nak kira guna formula. Okay, you masukkan sajalah A omega. You masukkan semula A is equal to 6, omega is equal to 2 pi. You darabkan, you tetap akan dapat 12 pi. Okay, tak ada masalah. Alright. And then A maximum, same goes to the first one. Okay, saya akan buat kat sini. Okay, so sebab kita dah ada A, equation A is equal to negative 24 pi squared sin 2 pi t. So daripada equation, saya dah tahu dah ini adalah nilai A maximum. Okay, this is the value of A maximum. Okay, so from the equation, the value of A maximum is actually equal to, okay, 24 pi squared. Okay, where it's equal to 236.9 centimeter per second squared. Okay, alright. So finish B and C, we want to sketch the graph, velocity against time. So kita dah buat banyak kali dah ni. So kalau you dah practice buat, tak mungkin you tak boleh buat. Okay, so graph V against time. So equation, look at here, the equation is in terms of cos. Okay, so the pattern of the graph mestilah graph cos lah. So jangan lupa letak dia punya unit. Okay, awak buatlah cantik-cantik So graph cos. So start daripada sini. Okay. So the period T tak ada, so kena kira. Tapi V dekat sini kita dah tahu. V maximum dia tadi berapa? 37.7 ataupun you nak label sebagai 12 pi. Pun boleh, tak ada masalah. So negative 37.7 and T here mesti kira. Bila buat graph, kira semua benda yang boleh kira. So omega equal to 2 pi over T. So T is equal to 2 pi over omega. Where omega here you dah ada dah nilai dia, which is 2 pi. Okay, where T is equal to 1 second. Okay, letaklah labelkan kat sini 1. Jangan biarkan dia T. Kira lepas tu labelkan dekat sini 1 lah. Which is the time taken to complete one oscillation. Boleh? Okay. And then for graph of acceleration. Okay, saya akan buat kat tepi ni lah. Okay. So look at here. This is the equation in terms of sign. Negative sign. Okay. So the graph of acceleration against time. So A centimeter per second squared. Oh, sekejap So T. So the graph should be negative sine graph. Okay. And the value here should be 236.9. So here should be maximum acceleration negative 236.9. And here is the period 1. Okay. So kita dah menjawab semua soalan dengan lengkap. Alright. So finish example number, this one 7. So we will proceed to example number 8. Okay, now example number 8. So here we have the particle of mass 300 gram. Okay, is suspended from a vertical helix spring. The spring is extended by 4 cm. If the mass is oscillating in a vertical plane, calculate the period of motion. Okay, now so let's try to sketch the diagram. So let's say here we have the helix spring. Okay, so this is the particle where the weight with the mass of m and g. Okay, so now we assume that the spring obeys Hooke's law. Then the force Fs pulling upward on the object, okay, by the spring is given by Fs. So we already know that. So we're gonna have the restoring force should be upward direction, and we know that the equation of restoring force Fs is equal to Kx. Okay, so at this position, since the object is in static equilibrium, so we consider the equation total Fy equal to ma. Okay, so in this case, we're gonna have Fs plus negative weight mg equal to 0. So Fs is equal to mg. Okay, so ini kena tahulah. So from here we can write the equation of K in terms of g, m and x. Okay, where K is equal to mg over x. Okay, boleh? So, kena tahu sikit lah ini. Okay, so we consider that the spring obeys Hooke's law. So, when the mass, okay, pulling the spring downward, so there is a force. We call it as restoring force that acts on the object. Okay, so we have the restoring force, okay, that we pull the object upward. Okay, and we can write the equation of total force in Y equal to MA, where this is static equilibrium, so we consider A is equal to 0. Okay, so dari sini kita boleh kira lah that K, the spring constant, is equal to mg over x. Boleh? Okay, so question number 1. So the period of motion. So we want to calculate what is the period of motion. Saya buat kat sini lah. T. So ini spring, kita boleh masukkan terus equation. So we can just substitute equation of period for spring 2 pi, okay, square root m over k. Okay, mass is given. Okay, kita nak cari T, tapi kita tak ada K. Okay, so daripada apa yang saya tunjukkan sebelum ni, tadi saya dah bagi tahu kan, how to get the equation of K. So we can calculate K is equal to mg over x. Okay, kita nampak the spring expand ataupun extend by 4 cm. So, kita tahulah, okay, K kita boleh cari by using this equation mg over x. Okay, so let's try to calculate where K is equal to M. Make sure mass in kg. Okay, 300 times 10 power of negative 3. Ataupun 0.3 kg pun boleh, lagi senang. Okay, 9.81 over x. Make sure x in meter. Okay, so nilai K you akan dapat 73, okay, 73.58. Okay, Newton per meter. So from here we can calculate 2 pi square root, okay, mass, make sure in kg. So mass is 0.3 kg. Okay, where K is equal to 73.58. Therefore, T you akan dapat nilai dia adalah 0.4 seconds. Okay, okay, yang ni siap. And then the frequency of its oscillation. So kita nak kira frequency. Remember, frequency is equal to 1 over T. Kita dah dapat T tadi. Okay, kita boleh masukkan sahaja. Okay, 2.5 Hz. And then the maximum velocity of the particle. Ini pun sama juga. Kita dah boleh buat. V maximum is equal to A omega. Okay, and A is the amplitude, where A is the 0.04 meter. Omega kita boleh cari. Omega is equal to 2 pi f. Okay, so omega is equal to, formula dia adalah 2 pi f. Frekuensi saya dah ada tadi. Saya masukkan je lah kat sini. Okay, so V maximum, you akan dapat nilai dia 0.63 meter per second. Okay, and then the maximum kinetic energy. Ini pun sama juga. We just apply the equation. Okay, so saya buat kat sini tak muat. Okay, maximum kinetic energy is equal to half Ka squared. Kalau kata tak nak guna formula ni, nak guna half m omega squared A squared. Tak ada masalah. Sebab m kita dah ada, omega pun boleh. Tapi kenapa nak susah-susah kan? So, saya hanya gunalah formula ini. Half Ka squared. K kita dah ada 73.58. And the amplitude must be in meter. Okay, squared jangan tertinggal. Okay, therefore K maximum is equal to 0.059 joule. Unit jangan salah. Boleh? Alright. Okay, so part B. Okay, part B. Jom kita buat kat bawah ni. So, a pendulum of length L oscillates with period T. So, we have the pendulum. So, letak T is equal to 2 pi square root L over G. Okay. So when the pendulum length is shortened by, okay, perkataan shortened by 50 cm means that L2 dia memendek sebanyak 50 cm. Dia akan jadi L1 minus 0.5 meter. Kalau sini kita letak L1 lah. Ini tadi L1 contohnya kan. So ini T1. L1 T1. So when the length of L1, then the period of the oscillation is T1. Dan sekarang soalan bagi kita condition when the pendulum length is shortened by. Okay. Shortened by maknanya dia berkurang sebanyak 50 cm which is 0.5 meter. So L2 and the period reduced to half T. Ni penting ni. Menarik soalan ni. And the period reduced to half T. Okay, means that T2 separuh daripada T1. Itu condition yang kita ada. Boleh? Okay. So sekarang, let's write the first condition. T1, okay, iaitu period of oscillation untuk the first case. Kita tulis sini case 1. Okay, sebelum kita pendekkan tali dia tu kan. So case 1. T1 equal to 2 pi square root L1G. So, kalau kita nak hilangkan square root, we can simplify by taking the square. So, kita akan dapat T1 squared 4 pi squared L1 over G. Okay, so saya akan biarkan ini sebagai equation number 1. Okay, but when L is equal to, when L2 is equal to L1 minus 0.5, second case. Okay, second case di mana L2 is equal to L1 minus 0.5. Okay, kita tulis dulu equation. T2 is equal to 2 pi square root L2 over G. Boleh? Okay, so saya simplifykan dulu. T2 squared equal to 4 pi squared L2 over G. Okay, so L2 ni kita dah boleh gantilah dengan L1 minus 0.5. Okay, saya tak muat, saya buat sebelah ni. T2 pula kita tak ada nilai, tapi kita tahu di mana T2, sekejap Okay, we already know that T2 is equal to half T1. Kan? T2 is equal to half T1. Okay, so kita boleh substitute lah. Okay, kat sini kita boleh teruskan. Where T2 is T1 over 2. Gantikan. Squared. Equal to 4 pi squared. L2 adalah L1 minus 0.5 over G. Okay? Boleh? Alright. Mana yang kita boleh simplify, kita simplifykan. Okay? So, saya buat balik semula. T1 squared, okay, over 4 equal to 4 pi squared L1 minus 0.5 G. Buat satu-satu lah. Jadi, yang ni boleh bawa naik atas ni. 4 bawa naik atas. Okay. So, dia akan jadi apa tu? Okay. So, this one should be equal to T1 squared equal to 16 16 pi squared. 16 pi squared. Okay. L1 minus 0.5 over G. Okay. So, T1 dekat sini. Okay. T1 squared boleh masukkanlah nilai ini. Boleh substitute. Okay, kita boleh tulis this is equation number 2. Okay, now let's try to solve the equation. Let's substitute equation number 1 into equation number 2. Okay, so T1 squared tu saya nak masukkan dekat sini. 4 pi squared L1 over G. Okay, equal to equation number 2 tadi 16 pi squared L1 minus 0.5 over G. Okay, So we can cancel out pi and this one 4. Okay. So kita boleh cancelkan juga G. Okay. So let's write L1 is equal to 4L1 minus 0.5 times 4 is 2. So rearrange the equation. Therefore, L1 is equal to, so 3 over 2. So L1 is equal to 2 over 3 is 0.67 meter. Okay, L1 ni yang first condition lah, L. Dia suruh kira L, tapi saya letak dia sebagai L1. This one the first condition. Okay, so kita dah dapat lah. And then we want to find what is the period T. T kita dekat sini adalah T1. Okay, T kat sini adalah T1. Okay, so now we can calculate T. Okay, where T is equal to, kita tak ada suruh kira T kan. So determine, okay, so T is equal to T1 lah. Okay, 2 pi. Okay, so sekarang kita nak kira T1, where T1 is equal to 2 pi square root L1 over G. Okay, so kita boleh kira lah. Okay, you just substitute the value 2 pi. L1 kita dah dapat tadi 0.67 meter over 9.81. Okay, therefore nilai T1, which is T1 is equal to 1.64. 1.64 seconds. Okay, so this is the answer for T. Okay, so finish example number 8. So let's proceed to the last example, which is example number 9.